Good day, everybody. My name is Eric Beauchesne. I'm a cybersecurity architect with Microsoft's EAG Security Division.
And my name is Richard Diver, and I'm the Director of Story Design in Security Marketing.
We're here to deliver a presentation on end-to-end security for the general AI infrastructure. The idea here is to present an idea that works on the fundamentals of infrastructure and cybersecurity, merged with new developments in AI security as well, to allow for a more holistic viewpoint of how to secure the AI infrastructure from front to back. What we're going to do is basically walk you through a few things that allow you to understand how, for one thing, the AI landing zone plays a role in it. And then we'll take a look at the common AI application architectures, highlight the key weak points that we need to focus on when we're dealing with the Gen AI infrastructure, and talk about the current mitigations that work, both from a foundational, fundamental aspect, as well as from one that focuses on the applications and AI-specific issues. And then we're also going to delve into the introduction to AI threat modeling, which allows us to have a very comprehensive viewpoint of how to secure an AI application from the drawing board on up. We want to make sure that we're actually looking at the session goals in a way that is applicable to everybody who's in the audience. We want to make sure that we understand the AI landing zone and AI applications and their specifics, talk about the attack points that are of a specific concern, and also what practical mitigations we can actually apply as Microsoft employees. What we'll do, though, is we'll start off with the application architecture. The important thing here is to understand the environment within which an application will exist within the Azure infrastructure. One of the things that we really want to point out is that when we're working with AI, we are also working in an Azure infrastructure. When we're actually looking at the concept of an AI landing zone, it's important to remember that there is really no one generic AI landing zone that we would actually land on. It is essential to understand that the AI landing zone can be pretty much whatever is necessary for the purpose of the application itself. Some landing zones can be simple or some can be very complex. The important thing to remember is that when you're working with an AI application within the Azure infrastructure, it is using Azure tools and technologies, PaaS services, networking services, as well as the backbone and other security devices. And that's what we really want to focus on here, is how we can actually leverage this infrastructure in a way that makes sure that the Gen AI application is as secure as possible from front to back. When we're looking at it, you're looking at the Azure services that are deployed. For example, you're looking at things like Entra ID, Key Vault, Defender for Cloud, Sentinel, Purview, the list goes on. The important thing is to have a clear understanding when you're actually working with a Gen AI application. What services and technologies are we applying to that application? And this will become a little bit more important later. Now, one of the things that we really want to focus on is not just the fact that it's an Azure environment, but who bears what responsibility for the aspects of a particular application. And Richard, I think that I'd like to basically share this sheet. We can actually talk about this one together.
Yeah, I really like the approach of the visual diagrams. The isolation of services, knowing what's going from left to right or north and south, depending on how you want to slice and dice your environment. But when it comes to the shared responsibility model, looking at how you built and design your Azure environment, you need to understand all these different layers. So we've put this into a nice 3-layered approach, which is the platform, the application, and then the usage. And I think by taking what you've presented there, Eric, and then using this kind of model, we can decide how much do we want to take responsibility for versus is it easier to just buy something off the shelf where a lot of those design decisions have already been made, right?
Exactly. And just like the cloud shared responsibility model, we're looking at the clear distinction between an IaaS environment, a PaaS environment, and a SaaS environment with respect to the AI application here.
Yeah, and then depending on which model you choose, you can see in the platform layer, if you bring your own model and decide to, or the customer decides to design, tune, build their own model, they've literally taken on all the responsibility on what that model does. And so what we see most customers doing is taking an existing pre-trained model and they're using an API to integrate with it. They might still do some level of tuning or retrieval augmented generation. And then depending on which model they choose, we have over 1,800 in the catalog today, and that will grow in time. Different capabilities and functionality comes with each one of those.
And I think it's important to point out that for the purposes of this presentation, we're really working with people who are looking at the PaaS, Azure AI model, as opposed to those who are creating their own model from scratch.
So if we take a look at the anatomy of an AI app, what we're looking at is the way to draw another diagram, which is my approach. And all AI apps can be looked at in a very similar way, which is we start with the user in mind, so top of that list. And the user is really, how are we expecting to interact with this AI tool? The prompt is generally the way the user's interacting. They may click a button, they might wave their hands, it might be video in the future, but mostly we're typing some kind of natural language into the prompt and trying to interact with the AI, just like we do a search or any other kind of writing in a Word document. And then that prompt is taken and moved ideally into an application for some sanitization before it gets to the LLM. In the early days of AI, we saw a lot of mistakes being made where the prompt literally went straight to the LLM, the large language model, and you would get some interesting feedback. And so the application layer is really where we get to put a lot of the controls in place to make sure that the user content, the user instructions, the intent is sanitized. And then also whatever comes out of that large language model, or now a small language model and multimodal models, whatever model you're using, we want to make sure the generated content is safe, along with any third-party integrations, skills, functions, plugins, all the extra resources that make this more and more complex. And so drawing a diagram helps you identify those parts as an application layer, and then go back to those landing zones and see which parts of those need to be separated and isolated for safety and security.
Exactly. I think that one of the big things we really want to point out here is the fact that the AI application itself is, of course, foundationally placed within the Azure environment using the services and technologies we talked about to create this particular model. So what we're going to do now is basically talk about some of the risks that are encountered with AI applications. Some of them are fairly traditional, the standard types of risks you see, but then we are also looking at risks that are unique and new that we need to make sure that we are anticipating and planning for when we're actually working with the creation and development and launching of an AI application. Now, in this particular one, Richard, we're looking at the actual threat landscape from beginning to end, aren't we?
Yeah, this is another way of looking at those same three layers. Now we're going left to right. And you can see from the usage perspective, there's the user, the application. Think about their devices, their identity, everything that is going to interact with your application. And so one of the first areas to think about from a threat perspective is very similar to today with email and phishing, is that issue that you might have where somebody might interject into the prompt injection and try to manipulate the system from the first stage of the application. After that, inside the application itself, we then have some additional issues to look at, things like which web sources do we go to, what data can I get access to, and maybe what other applications are we interacting with.
I think that the idea of like the applications going out for more information is also another one from a supply chain perspective that is a further risk that we also have to make sure that we are anticipating.
Absolutely. And then after all of that, we look at the actual model itself and say, when we choose our model and we choose our data connectors, there's this thing called a jailbreak. And the idea of a jailbreak is trying to get the system to do something that the designer didn't want it to do. Now, if you take any model today, there are a lot of different jailbreak techniques, and those jailbreak techniques can produce harmful outcomes. So the plan is to make sure you've got the mitigations in place to, one, prevent the harmful content going in. That was the defenses against things like prompt injections, etc. But even just benign use of the system might cause something like a jailbreak. And so we want to be able to monitor that, detect that, and then watch for any kind of activities and then tune the system to prevent it as well. Last worry on that, though, is on things like model theft or data poisoning. So if you have access to the model itself, or you can manipulate or change any of the code of the model, then you could end up with some other vulnerabilities that are deeper inside the system. And this is another reason why we see a lot of companies don't choose to play around with models themselves and stick to using the API into a well-known, well-defined, pre-trained model.
Yeah, and I think that's very, very important to point out that one of the issues with a model is if we find that a model has been corrupted, you can't fix the model, can you? You have to pretty much start over again.
Yeah, there's no patching. You can't just redeploy the next one. So we do see new models coming out on a regular basis, and each new model comes with normally a greater set of capabilities, and they become smarter and smarter every time, which means sometimes the defenses we had in place before are now weakened by this new fantastic capabilities. And so it is some continuous testing, but the application of mitigations and defenses are more likely in the application space. So we could say the platform space if we're thinking of filters and the ways that we protect it, but a lot of it is inside the application to, again, prevent harmful content in, harmful content out.
So we'll break it down into the actual jailbreak specifically.
Yeah, here's a good example of a jailbreak. It could be quite benign. We use the bomb example because normally in an enterprise environment, we're not looking to build some kind of bomb. And so it's quite simple to put guardrails in play and say, don't ask me about that topic. Let's do something different. And you can pick any topic. As you can see in the result, though, the result is that because we changed the word bomb was filtered out before and said, I can't help with that. Now we try using ASCII characters, and by creating ASCII artwork, this is one of the techniques that worked a while ago, and ideally everything's been mitigated. As soon as you defined it, you can then mitigate it. But now the AI is smart enough to see that we're not saying the word bomb, but by drawing it in ASCII artwork, we're actually using the word bomb. And this just goes back to ideas like what other languages, what other visuals, how else can we manipulate the system in a way that we get the results we want back, but we get around any of the filtering we put in place for that. So this is something good to consider. Again, the 3 layers helps us to not only look at each individual layer one by one, but think about the whole attack lifecycle from beginning to end. So the risks and harms of AI are really at that usage level. And this is up to every company and organization to decide how do they want to use AI in their environment. What are they allowing or not allowing from an ethics or privacy, fairness kind of risk that company is going to take on by incorporating AI. As we get into the application layer, we're certainly looking at things like prompt injections, content poisoning, and then into the infrastructure we choose to build our applications upon and down into model attacks. If we just take a look at malicious prompts and poison content, different kinds of prompt injection attacks, ideally what they're going to do is lead to some kind of jailbreak. The jailbreak is then what we're trying to prevent, because it's the jailbreak that actually causes the harmful outcome. It might allow access to data the user wasn't intended to have access to, some kind of extraction of information, or even actions being taken, especially as we get into an agentic system. A jailbreak could lead the system to carry out actions that the user wasn't authorized to do. And so we create a defense in depth approach to that. And that defense in depth allows us to create many mitigations in order to protect from that.
And so I think this really boils down to a number of different areas that can be considered to be threats. But we've actually got 3 top customer concerns that are going to be addressed here. One is, as we talked about, the compromise of sensitive data. The other is the prompt injection attacks themselves, either direct or indirect, and the jailbreak techniques that exist to actually attack a model. And the defenses and mitigations that we can actually provide as Microsoft personnel are actually able to effectively address these concerns in a very, very targeted and comprehensive manner. So let's talk about that now. So what I'm going to do is talk about the mitigations at the foundational layer. And then Richard will talk about the mitigations more at the application layer, especially with some of our technologies that are out there. Now, one of the things to review and go back upon is the fact that we were talking about the foundational aspects of the Azure infrastructure that are used to create the AI landing zone and the area within which the AI application will actually exist. So when we're actually looking at this, one thing to remember is that this is an Azure infrastructure, just like any other. And as such, we have to make sure that we're securing them according to the Microsoft Cloud Security Benchmark. Now, the benchmark itself has very, very prescriptive and targeted guidance and practices around how to secure the infrastructure along a number of different focus areas like network security, identity management, privileged access, incident response, data protection, DevOps security. All of these areas put together allow us to actually have a very comprehensive approach to securing the Azure infrastructure. And that is what we would still use with an application, even if it's an AI application. It allows us to secure the actual services, the workloads, the data, and all the services within the Azure environment itself. Now, it is important to look at it from a holistic perspective for sure. But one of the things we also want to make sure of is that we are looking at enforcing security for every service that's in there. So the Microsoft Cloud Security Benchmark, having a comprehensive approach, also has specific targeted security baseline recommendations for every single PaaS service that Microsoft offers. And what it does is provide very prescriptive guidance on how to protect data, whatever is relevant to that particular service itself. So if identity is important, or if the network security is important, or backup and recovery, all of these are basically be covered in the security baselines. So we try to take both a holistic approach using the benchmark itself and a more targeted tactical approach by securing each and every single PaaS service that's in there. And when we actually take this approach, we're actually trying to provide something that's very, very holistic, but also essentially covering all of the actual services. And this will take care of more than 90 to 95% of the potential threats that are there because it deals with securing your data, segmenting your network, making sure you have access controls in place so that the infrastructure itself is being properly protected in a way that is covering the entire environment, but also covering the specific aspects and resources within there. Now, the security baselines are available for review in the Microsoft Learning website. This is a must-have. This is absolutely essential to making sure that the Azure AI landing zone is secure. Once you've actually done that, it's also important to remember that when we're looking at the foundational infrastructure itself, the overall environment, it's also important to make sure that we realize that we're dealing with AI workloads as well. And this is where we actually start looking at the application. So we've looked at the foundation. Now we need to take a look at the applications. And with respect to the applications, we look at specific parts of the Cloud Security Benchmark for guidance, dealing with data protection, identity management, logging and threat detection, incident response, and DevOps security. These are the 5 most important areas to look at when we're dealing with AI workloads. And to give you an example of how that all aligns with the model that we had before, we had AI usage, AI application, and AI platform. So the 5 focus areas we have basically present technologies and solutions that can actually address all 3 levels as we go through. Purview, as you can see, for data protection is prevalent and prominent at all 3 levels. Basically protecting the data that's going in, protecting the data that's generated, and protecting the data that exists. Identity management is also very important, not just the use of Entra ID as a central controlling source for all identity authentication and administration, but also using things like Defender for Cloud App that essentially regulates access to the applications themselves, including AI applications. With logging and threat detection, we have Defender for Cloud. Defender for Cloud Apps, we have insider risk management. We have the Azure AI service itself, which actually provides its own protections, as we will see in just a little bit. And also Azure AI Content Safety, which is used in the development of the applications themselves, which we'll also expand on. For incident response, of course, we have Sentinel to actually provide that centralized security operations resource and dashboard to essentially recognize the signals that are coming in, to have situational awareness, to be able to respond to incidents that would come up in a rapid, automated, or manual fashion. And with DevOps, which we will talk about a little bit, you also have Defender for Cloud, but you also have GitHub Advanced Security to assist with the proper development of these applications. All these put together allow Microsoft's technology to basically provide a great degree of security as a wrapper around the applications from a foundational perspective on up. Now, Richard, this particular one, I think, really illustrates the integrated nature of the security at the application level.
Yeah, there's this new feature or product that we have now called the Azure AI Foundry. And so while we have to protect all the things we know about from a standard application perspective and infrastructure perspective, as we get into AI, there's this need for unique and specific tools that are looking at things like language issues, which is mostly what this AI problem is we're using human language. And so Azure OpenAI is one of the flagship models that we're using. And so there's a lot of protections built in and around that service. But also the Foundry does cater for all the other 1,800 different models that we have as well. And so in the content safety side, we can see we're looking at things like content moderation, different to the kind of idea of sensitive data. This is just the wording of sensitive might mean something that might be against things like violence or, some, as I said before, the words bomb. Depending on which kind of environment you're in, certain things don't want to be said or released. And then we get into prompt shield, which is looking for that attempts to attack the system or even successful attempts. And then any other kind of protective materials. This might be things like nuclear kind of weapons or biological weapons, anything that might be of a harmful nature. And then groundedness detection is another useful area. If you think of when we use AI inside of a search result on Bing as a good example, you want to make sure it's actually grounded in truth and not just some hallucinations. Hallucinations can be a lot of fun. You can make some very interesting stories and pictures, but when we're looking for factual information, we need it to be grounded. And so all of these capabilities are built into the Azure AI Foundry for customers to use as they build out their own PaaS platforms with AI integrations. So it's really important to understand the idea of helping the customer start secure, and then ongoing AI is rapidly changing and evolving. And because, again, we're dealing with language, we are going to continuously look for new ways to attack the system. And so stay secure matters.
It does. And I'd like to point out that a lot of the vulnerabilities that these technologies are looking for are grounded in data protection, identity management, and other areas that should be covered with a cloud security baseline. So if you've actually designed it from the foundational level on up properly, then you should not be getting a lot of risky threat signals coming from here. But these are here just in case.
So one last thing, Eric, is the idea of getting into threat modeling or threat mapping, helping a customer understand how to actually assess the risks and then appropriately address those risks. We have this really nice diagram that explains the idea of shift left all the way through to what is on the right is operational. So the sooner we get into designing safety and security into an AI system, the better. That's no different to any other application, but it's especially true for AI. In this model, you can see that we've highlighted a few areas like threat modeling specifically for AI risks, getting into testing, things like dynamic testing, not just, you can't just do a one-off pen test and we're good. You need to continuously carry out some kind of red teaming. And also, as you look at the incidents that are coming in, it might be from your own users, or it could be some third parties that explain to you some of the risks and issues they're seeing in your system. You need to react to those very quickly. As I like diagrams and I like drawing a lot of these things out, I have one simple template to show you. And this template will just allow you to start these conversations as you think of your own ideas. The next time you read a story of some incident or event that happened, work through from left to right. What happened from the user perspective? How did they interact with the system? What could we have done to ensure they were the legitimate user, that the content they were using was appropriate for the application they were working with? And then in the application itself, what kind of processing could we do to try to detect or prevent a prompt injection? We assume breach. And so let's say we're going to miss all of that and we're going to get to a jailbreak. How bad can that jailbreak be? If it's only, so say, bad language being sent back to the user, that's not as serious as the user getting access to sensitive data they should never have had access to. And so using this kind of model, mapping it out and drawing it, we found to be extremely useful when communicating with different teams and helping us to actually share the idea of risks, threats, and mitigations.
And that wraps up our presentation. We tried to walk you through the end-to-end security for AI landing zones and applications, understand our defense in depth approach to generative AI, and which tools to deploy in practice. So we want to thank you for listening to this presentation, and we invite you to please feel free to contact Richard and myself if you have any questions, and we'd be very happy to discuss this further.
Thank you, Eric.
Thank you, Richard.